maybe.
Hello?
All right, so for a rectangular coordinate, we need two things. We just need an x, and we need a y value. Well, x is associated with cosine, so we'll use cosine as the exact value to find the x, and then we'll use sine as the exact value to find the y. Only thing we'll need to add into it is how far the radius takes us. So we'll just do the radius times the exact value based on the angle we're given. I'll just do it because I think it'll make more sense of just doing it, all right? So to get it into rectangular, we'll do the radius, which is 6, times cosine of the angle we're working with. So it'll be times cosine of pi over 6. This is just an exact value that we'll find.
Is that a B?
That's a 6.
Oh, sorry.
No, I'm sorry. All right, and then to get the y coordinate, it would be the radius 6 times sine of the same angle. And just simplifying this will give me my rectangular coordinate. All right, so since it's over 6, this is a 30. What is cosine at all of the 30s? 3 over 2. So I got 6 times root 3 over 2. Should it be positive or negative 3 over 2?
Positive.
Positive. Positive is correct. How'd you know it was positive? Which quadrant is this angle in?
1.
What's cosine's sine in the first quadrant? Positive or negative?
Positive.
So you go with the positive option. Same thing for sine, right?
Yeah.
If cosine was 3 over 2 at this angle, what would sine be?
2 over 2.
1 over 2 is the match. So 6 times 1 over 2. Can I reduce these two?
Yeah.
6 divided by 2 is 3. Over here, same thing. 6 divided by 2 is 3 as well. So converting it to rectangular coordinates gets me here. Well, this is my x, this is my y. So if I think about graphing this one, I would go up 30, out 6, somewhere there. If I followed these coordinates, I would go right 3 times root 3. Then I would go up 3, take me to the same exact spot. All right, so what we did basically was we needed to get x and y. We just used this formula, this setup. You take the radius, you multiply by the exact value of cosine. Take the radius, you multiply by the exact value of sine. Let's do another one. For number 2, what's my radius? What's my r? So I'll do negative 4 times cosine of, what's my angle? Negative pi over 4. Then for the y, I'll do 4 times sine pi over 4. Negative pi over 4. Well, at the 45s, both of the coordinates are what? Root 2 over 2. So negative pi over 4 is in which quadrant?
First one. Fourth.
Negative pi over 4. Fourth. You said it, fourth. So what's cosine sine at negative pi over 4?
3 over 2. Negative.
Positive.
It's positive, as Drew said. I might have asked the question wrong. If this is my reference angle for a 45 in the fourth quadrant, it'd be 2 over 2 and negative 2 over 2, right?
Yeah.
So the x would be this one, the y would be this one, for a 45 in this one. No, because it's 45. It's a 45 angle. So this would be my y sine. This would be my x. Oh, you're right. I wrote them backwards. Sorry. All right, so cosine would be the positive one. Sine would be the negative one. Does that make sense? You could also do even odd functions. Since cosine is even, this negative sign doesn't even matter. So I could do just cosine of 45, which would still be 2 over 2. So negative 4 times root 2 over 2. It's going to give me the x-coordinate. And since sine is an odd function, I could take this negative out and make, this should be negative 4, make the whole function negative. And then I would still get the same value. That's what the odd function does. But since we're at this point, I'll go ahead and do negative 4 times negative root 2 over 2. Is everybody okay with these exact values?
Yes.
This is cosine of negative pi over 4.
Yes.
And this is sine of negative pi over 4. All right? And then we simplify like we did last time. I think I can do negative 4 divided by 2.
Negative 2.
Yep, so I get negative 2 times root 2 for my x. For my y, I get a negative and negative makes it positive. 2 root 2. And it makes sense that the coordinates are the same numbers since it's a 45. So this is rectangular and I got my x and my y. Guys have any questions? All right, you guys take a second and try these two on the right. Huh? The squiggly? Just the separating line? Yeah.
Okay, sorry. I thought I was supposed to get that for 1. Like I wrote.
No, this is 1. This is 2.
Why is it negative 1 over 2?
Right here? Because my angle is 2 pi over 3, and that angle is right here.
Oh, never mind. I got it.
Okay. So yeah, 1/2, 3/2.
Right, right.
All right, so this is cosine of 2 pi over 3. This is sine of 2 pi over 3. The reference angle would be a 60 since it's over 3. At the 60s, cosine is 1/2, sine is 3/2. Since it's in the second quadrant, I chose the negative option for the cosine value. And then from there, I just simplified it. 4 divided by 2 is 2. A negative and a negative make it positive. Here, I still do 4 divided by 2, but I still got my root 3. I had a negative 4 times a positive number, so it left my term as positive. And then down below, since it's over 4, it's a 45. I knew my coordinates would be the same. This angle's in the fourth quadrant. I just go counterclockwise. I go clockwise, 45 degrees. So it's in the fourth quadrant. And in the fourth quadrant, cosine's positive, sine is negative since I'm down. So that's why I chose those values. And then I can't simplify 5/2 and get a whole number, so I just leave it as a fraction. So what I got? You guys feel okay about this?
Yeah.
So it's probably a little more straightforward than converting the other way. All right, but this is going from polar back to rectangular coordinates. All right, no questions? Everybody okay?
Does it get harder?
No. Not, you mean the section or? It doesn't get harder, no. It doesn't get harder. This next concept's pretty straightforward, kind of like a coterminal angle. So you don't have to write this, but let's say I just had a random point and my point was 2, 1. And this is a rectangular point. I got an x and a y coordinate. If I go to plot it, I would go right 2, up 1 to take my point to this location right here. Now for an x and a y value, there's really no other way to get to this specific location in the coordinate plane, right? My only way is to go right 2, up 1. So there's only one pair of points or a pair of coordinates that get me to this location. All right, now when we have polar coordinates, we can get to a specific location in an infinite number of ways, just by either adding or subtracting 2 pi or doing one other change. All right, so when given a point in the plane, we can only have one pair of rectangular coordinates, meaning there's only one pair of points that gets me to a specific location in rectangular. But when we convert to polar, there's an infinite number of ways we can get to a specific location. All right, so let's look at what we can do. It's very similar to coterminal angles where you just add or subtract 360 or 2 pi. So if we start off with this point right here, where r is 3 and then theta, my angle, is 140, we want to give at least 3 different ways we can get to this same location, but with a different point. So there's 2 ways you can do this. The first way is you can keep the same sign for your radius, r, and then you can either add or subtract 360 if you got degrees, like we got. But if you had a radian measure, you would either add or subtract 2 pi, just like coterminal angles. So if we wanted to find another point, we'll call this point 1. I would keep the same sign for r. I don't change anything with r, but I take my angle measure and I either add or subtract 360 to it. How about we add 360 to this?
It'd be
500 flat?
yeah.
Yep, 40 and 60 is 100. 1, 3 plus 1 more. 500. Was that mental math?
Yes, sir.
Good job. So 500 takes me to the same spot. As you copy this, just to show you. With the first point, I would go 140, which is in the second quadrant. Then I would go out 1, 2, 3. Maybe the point's somewhere there. For 500, I would go around once. Then I would go around 140 more, taking me to that same line. Then I would go out 1, 2, 3 again. So the points are literally right on top of each other. All right, so I could add 360 again and I get another point. I can do 360 again until my arm falls off and I just keep getting more points there in the same spot. Does that make sense?
But why are we on 500 again?
Why do we get 500? Because we wanted to find another point in the same location, and you just add like one more circle to it.
Oh, okay.
So you basically just add one more time around.
Could you do like a negative and go the other way?
Let's see. And the rule says adding or subtracting 360. So let's see what happens when we do that. So let's get another point.
No.
You don't think so, Drew?
We have to.
Well, we got to get 3 total. So if we wanted to, we could add 360 again, and we get what, 860, and that would be another point.
You're getting the same answer every time. Aren't you
You're
getting
getting you're getting to the same spot every time,
140?
but you're getting a different point,
But why?
like a coterminal angle.
You're just adding 360.
Just adding or subtracting 360. All right, so we'll go back to our original value, 140. And this time we'll subtract 360. Drew says we won't get to the same spot. Right, Drew?
No, we can.
You think we can change?
I didn't want to do it.
You think we will? All right. So I didn't change R. It's still positive 3. I'll subtract and I get, what do we say, negative 2,
Negative 220.
220?
It's already
Oh,
right
wow.
there, Doc.
Oh, man, I must have did this early.
No, I'm looking at-
All right, negative 220. Okay, so we subtracted 360 and we got negative 220. So 140 was in the second quadrant right here. Let's see where this one falls. Which quadrant is negative 220 in?
Two.
The second. So I would go 90, 180, and then 30 more. Take me in the second quadrant. Then I would go out 1, 2, 3.
What do you mean 30 more?
30 more than negative 180?
40 more.
30 more than 180,
Oh, it is 40 more. I'm sorry. You're right. It is 40 more. My bad. My bad, Drew.
23, not 10 degrees.
Yeah, you're right. My bad.
He told you.
He did tell me, didn't he? Right? Same location, other than my human graphing. It just might not look the same. Same location. Does that make sense? If it was a radian measure, you'd add or subtract 2 pi. So that may be a little bit harder. So for example, if you had like, let's say we had 1 and pi over 6. We wanted to find another angle. I would add 2 pi. But obviously I would need a common denominator. So this makes this a little bit more, I don't know, annoying maybe. So instead of me adding 2 pi, I would convert 2 pi to 24, not over 6, so not over 12, over 6, I'm sorry. So I multiply by 6 over 6. And then what I would get, it would be 12 pi over 6. Is 12 pi over 6 the same as 2 pi?
Yeah.
It is, so that's what I would add to this. And then I would get another angle of 13 pi over 6. So if it was a radian measure, you would have to convert how your 2 pi looks, maybe, which maybe makes it a little bit hard. All right, but the process is the same. So that's one way we can do it. The second way we can find another point is we can take the opposite sine of r, and then we add or subtract 180. All right, so let's do that. So my r was positive. What's the opposite side of this being positive 3, the opposite sign? Negative 3, so I make it negative 3. And that's going to make me go the opposite way, right? So instead of me having to add or subtract a full 360, I would just add or subtract 180, because I've already done half of it just by going in the opposite direction. So I only need to add or subtract 180 to it. So you want to add it? All right, let's add 180 to this. And let's see where it puts us. So I get negative 3. 320?
I think so.
I think you're right. 4 and 2 is, yeah. So I get positive 320. All right, let's see where this takes us. It should take me somewhere in the second quadrant, right?
Yeah.
Which quadrant is positive 320 in?
The second one.
The fourth. The point's in the second one, but I would go 90, 180, 270, and 50 more, right, Drew?
Well, I was thinking, yeah, 50.
Okay. And then I wouldn't go in this direction. I would go opposite 3. So 1, 2, 3. And this point looks kind of similar to the rest because I should be in the same location. All right, so this is the other way to find a point that's in the same location. It's a different point, but it's in the same location. Does that make sense? So just like with the coterminal angles, the way this question will probably be presented is maybe it'll say, in this situation, it'll say, give me a radian measure that's less than 0, and it's between, maybe it's greater than 0, but it's less than 360. So then you say, oh, I need to make, what kind of numbers are less than 0? Negative. So I'd say, oh, this needs to be negative, and this angle needs to be 320. So you would choose how you want, which one of these you wanted to do to meet this criteria. And that's the angle you would choose. Maybe you want a positive R and an angle that's negative. Then you would just add or subtract, change your sign if you need to, use one of these methods to meet the criteria you were given. Does that make sense?
Yeah.
All right, if it says just give another point, then that's easy. Just choose what you want to do. All right, so let's kind of combine those pieces to do this last one. And I think we will be good to go with plenty of time to maybe even finish your homework and then get ready for wind, because we got wind today. Which is kind of random, but. All right, so we want to determine 2 pairs of polar coordinates for the point with the rectangular coordinates. So we're given a point in rectangular coordinates. We want to find 2 pairs of polar coordinates for the same rectangular point. So now this formula to find more points, is this for a rectangular point or for a polar point?
Polar.
It's for a polar point. But this is given to me as a rectangular point. What am I going to have to do before I can find other polar points?
Change it.
So I'm going to have to convert from rectangular to a polar point first. All right, so that's the first thing we're going to have to do. We're going to go from rectangular to polar. So that's step 1. And then 2, we'll say find other points, find others. All right, so let's convert to polar. And even if it didn't jump out at me that, hey, this is a rectangular point, how would you know this is probably a rectangular point? What would jump out at it to you? Yeah, the root 3, probably the 1. I mean, what would this 1 be? 1 radian, 1 degree? Like, that doesn't really make sense. If I go over here, it could be 0. But over here, I'm thinking like, this should be like a degree measure or an angle measure, some angle measure. So this is rectangular. This is an x and a y value. When we convert, what's the first thing we do? And what we're doing is what we did on the front page here. What's the first thing we did when we convert from rectangular to polar?
Always plot the point first.
Always plot the point. That's a good idea. How about we do that? I think I'm going to go left and up. Second quadrant, I'll go left, negative root 3. Then I'll go up how many? 1 to take me to this point right here. I'll turn this into a right triangle. My apologies.
That was easy though.
Oh, okay.
It's only like an inch.
Oh, okay. How about you go up there and write a perfect triangle
On what?
on the board? Oh, it's curved. It's curved. What are you doing?
That was aggressive.
What are you doing? It's curved.
That one's not curved.
It was curved.
He's Picasso. That's not bad, Drew. He's kind of got you there.
That is pretty good.
No. Did you see his first line?
No, I didn't. He was in the way.
Did anybody see his first line?
I did.
Was it curved?
The first one, but then he fixed it.
Yeah, now it's
Let me-
perfect.
Let me fix mine.
Yeah.
Let me use an eraser like Drew did.
He's gonna leave it up there.
You gotta erase it, Drew.
Oh.
Again,
Use that little car wash thing.
unlike I was able to do.
Oh, no.
No, your triangle, so we can see the notes.
All right, maybe Drew should draw all my triangles. How about that, Drew?
I don't know, that was a pretty good triangle.
After he erased it. You guys didn't see that. He did it so quick and he was blocking it. You guys,
Yeah, I can.
somebody's my witness. You saw it, right? You saw it? Did you see it? It was curved, wasn't it? Drew, you know it was curved, don't you? Exactly, exactly. If I had an eraser, I could do that. Don't try to show me up on my triangles, man. All right. So just imagine this is a triangle. I know it's probably difficult. Just imagine this is a triangle. We want to find R, right? How are we going to do that? Pythagorean theorem. Did we already do this? Two? So we could do it again. By all means, we could do it again. 1 squared plus root 3 squared. 1 plus 3, square root of 4, 2. We could do it again 100%.
We don't need to.
We've already done it though. Hypotenuse is going to be 2. So as I'm converting, we've already found R. We need to figure out R. We already found 2. Can I turn this into a 2? That was pretty good. Yeah. A complete turnaround.
Two?
That's a 2. We're not doing this today. We're not doing this. Okay, what else do I need to find now? I got R. What else do I need?
Oh, put the line through it. Delta.
Theta. Theta. Or you could say the angle. Okay, how am I going to figure out what angle this is in the second quadrant? I see 1, 2, divide something.
Root 3, so it's probably,
I think it's
wouldn't that be like tangent? Not tangent, it would be,
120.
isn't it like 1 over root 3?
Negative square root of 3 over
150. It's 150. How'd you know that?
I looked at my sheet.
Your unit circle?
Yeah,
How'd you know which one to look at though? I see a lot of root 3s and a lot of 1s.
because it's the only negative one in the second
Yeah,
quadrant.
150, where she said.
Where X is negative? Yeah, that's a good observation. What you basically did without even knowing it was, you said, I should have wrote it up here. You said, let's see what cosine is at this situation. Cosine is A over H. What's A?
Three.
Adjacent, negative root 3. What's over 2?
Yeah.
2.
And so if you look at your unit circle, you'll say in the second quadrant, because that's where we are, when is cosine negative 3 over 2? And you'd say, oh, at 150. So then you'd come here and you'd say this angle is 150. You could also did sine, just so we see that it works. Sine is O over H. The opposite side is 1. The hypotenuse is 2. When is sine 1 over 2? At 150 also. Does that make sense how we find that angle?
What? What'd you say?
Makes sense. Does it make sense?
Yeah, it
it's
makes
a lot
sense to you.
easier than me looking at it.
I agree, but you can't always look at it though.
When they're all positive.
All right. Questions how we got here? So our goal was to find 2 pairs of points. What can I do to find another point?
Plus 360.
Okay, let's do that. So do I change R? Do I change the sign of R?
No.
No, I just literally add 360 to it. And I get 2,
Wait, are we on number 2 now?
510. Nope, still on number 1.
110 plus
That's it.
500.
I was glad I said it first.
That's not important though. This is one other point. How can I find another point? Let's do something different. Give me a point that is, give me a point that has a negative angle and a negative radius. So R is less than 0 and the angle is also less than 0. What would I do to this to meet this criteria?
-2, and then you can something with 180.
Okay?
Subtract 180.
So I can make my R negative by taking the opposite sign. When I do that, my only options are to either add or subtract 180. Since I want a negative angle, what would I do to 150? Would I add or subtract from
You
it?
gotta add it. That's what we did
Subtract.
at the top, we added it.
We did, but
Subtract.
if I want the angle to come out negative, I gotta subtract to get a negative angle.
So -2.
Are we gonna make 2 negative or no?
Yeah.
Yeah,
Okay, but at the top, we did 3 negative, and we added 180.
you're right. But here's why we subtract. Because we want the angle to come out to be negative. So we have to subtract. That's the only way we can meet this criteria right here. So you're not wrong. You can do that and get another point. We're trying to get a specific point though. It still doesn't make sense though.
It does.
Okay. But you're right. You could do that 100%. So we'll change the sign to make it negative. So we did the first one, check. Now we got to get a negative angle. So if I start off with 150, I would ask myself, and we already did this, but my thinking would be, what would make this angle negative? I got to subtract. So minus 180, and that gives me -2, negative
30.
30. So then I would say, is R negative? Yes, check. Is this angle negative? Yes, check. Now, if we wanted an angle that was bigger, less than -360, what would I do to this?
Bigger and less.
Negative, and
Negative.
I would subtract what to make this. How about I make this more negative? What could I do at this point?
Add.
If you have -$2 and you get more negative, you would like spend more money, so you would subtract from what your already negative number is.
So subtract 180.
Well, I would have to change the sign if I did that.
360.
Yeah, I would just subtract 360. -2, -390. That's another point. More negative. All right, you guys feel okay about 1? Do we need to do 2, or feel okay?
I think we're okay.
I think we're okay.
I'm okay.
All right. All right, we got some practice problems to work on. You probably finish it before we even get out of here. Let me know if you need any help.
We had enrichment today.
Yeah, that's what they said on the intercom.
Oh, it isn't here.
Yeah, they said we got enrichment today,
Yeah,
so
last one's on there.
11:25. Yep. We get out at 11:25. Yes. You could probably start, and I might go over one. Yeah.
I have to do.
Good.
Dibs. Fucking bother her. I can't have dibs. I kinda got two. Don't care. Did you get our test yet? No, so that wasn't. That was probably the study guide. Oh, yeah.
Elliot, do you have a help sheet, or do you need a?
checked, really,
Yeah, I got it.
we got a 90. I have all of it.
I gotta use one hand.
Be the edge, man.
I said Alex.
So weird.
I like to pray.